Hello everybody, my name is Sharon George and today I'll be explaining a program to you. It's a program related to data structure, queue data structure. So first of all, let us have a look at the question. So that's our question, the array implementation of queue. To simulate the working of a queue of integers using an array with the following operations. So we have to perform certain operations here. The first one is insertion, second is deletion, third is displaying the elements in the queue, and queue full and queue empty. If the queue is full, then you have to display a certain message, and if the queue is empty, a certain message to the user. So before we begin with the program, let us understand what is a queue. So here if we go, carefully look at the image. Okay, it's loading. We'll look at it here. So a queue has two parts, front and back. Here it is given front and back. The exact term is rear and front, right? So rear is the place from where the insertion will happen. I hope you can see the image. Rear is the place from where the insertion will happen in queue, and front is the place from where the deletion will happen. Initially in a program, you declare rear and front equal to -1, which states that the queue is empty at this moment. So whenever you have to, if you go and try to see another image, if I take this image, as you can see, whenever you insert an element, you insert it from the rear part. Here it is given back, the right term is rear. When you insert an element, you have to increment rear and then insert this element, right? I hope you understand that, because back is here at this moment, rear is here at this moment. If I want one more element here, I have to increment rear and then put that element in that place. And similarly, if I have to delete an element, then I have to increment the front again, and then the particular element will be deleted. Whatever comes in between rear and front is a part of the queue, and whatever is outside it is not a part of the queue, right? I hope you understood that. Now I've made a program here in code blocks. Let's just see the program and try to understand what is a queue. So you begin by including the header file and then the standard library file. Since we have to display functions for inserting, deletion, and displaying, I've declared certain functions here. First one is enqueue, void enqueue parameter int. This is for insertion of an element. Then dequeue, this is for deletion of an element. Display, for displaying the elements. Int is full is the function to check if the queue is full or not, and is empty is the function to check if the queue is empty or not. So we begin by initializing certain variables, that is a rear, that is the back part, equal to -1, and a front equal to -1. This is because this is the beginning, and in the beginning the queue is empty. There are no elements present in the queue, and since -1 is not a valid index, it means the queue is empty. N is the size of the queue. Data is the element that is to be inserted or displayed or deleted, and A10 is the array which we are going to use for the implementation of queue. So let us come inside main. And now inside the main, since we have to make a menu driven program, I have declared a variable called choice here and ch of character type. So I begin by asking the size of the queue and taking the input. Now we have used a do while loop here. We've used a do while loop here because the menu should be displayed at least once, irrespective of the choice of the user. Even if the choice is not right, the menu should be displayed once. So in do while, since the condition is checked at the end, so even if the condition doesn't match, it will display its statements at least once. So I've used a do while loop here, and I've given various options: enqueue, dequeue, display, and I've used a switch case here. Case 1 is for entering the element, so enqueue data. Case 2 is for deleting the element, and case 3 is for displaying the element. So in case 1 I call the enqueue function, in case 2 I call the dequeue function, and case 3 I call the display function. And if the user enters a choice which doesn't match any of these three choices, then you have to display a statement invalid entry. And if the user wants to continue, he will press Y or Y, small y or capital Y, and you can also add a statement here, or else press any other key to exit. Yeah, so that's it. So we have ended with main. I've given a return statement here because I've initialized main int main. Now let us come out of the main and start defining the functions which we have used. So first function is empty. Is empty is a function which is used to check if the queue is empty or not. So when will the queue be empty? Let us go back and check. As you can see in this diagram, when rear and front will become equal, there will come a point when rear and front will become equal. If rear and front becomes equal, that means the queue is empty because they both point towards one position. So queue is empty at that moment, right? So if A front equal to A rear, return 1. That means the function is true, is empty, it is empty. Else return 0. If this condition doesn't satisfy, you return 0. Since we are returning 1 and 0 here because the data type of this function is int, return type is int, right? Int is full. This function will check if the queue is full or not. So for a queue to be full, the condition is that the rear should be equal to max minus 1. For example, if the queue size is 5, then rear should go up to 4 because it starts with 0, 1, 2, 3 and 4, right? So if you assume this is the queue size, you don't consider these two other blocks, just consider these 5 blocks. Then if back or rear here is equal to, so this is 5, right? Maximum size is 5, and if you number it 0, 1, 2, 3, 4, back is equal to 5 minus 1. So in that case, rear is full. This is a linear queue. You have something called circular queue. Conditions differ there. So in a linear queue, if the queue is full, then the condition is A rear equal to n minus 1. If the condition is true, you return 1, else you return 0. Now let us come on to another function, void enqueue int data. This is the function which is used to insert elements, right? For inserting an element, you have to first of all check if the queue is full or not. Because if the queue is full, where are you going to enter the elements? Where are you going to insert the elements? So if queue is not full, so if not is full, then what you can do is you can increment rear, because I already told you in the beginning that if you have to insert an element, you have to increment rear, and in that place you store the data. So A of A rear data will be stored in that position. Else you have to display a statement that queue is overflowing if it is full. Then you come on to the dequeue function. For dequeue function, you have to check if the queue is empty or not, because if the queue is empty, what are you going to take out from the queue? What are you going to delete from the queue, right? So if it is empty, if it is not empty, then you have to increment front, and you have to declare another variable which will store that value, and that value will be displayed as the deleted element, right? Else you have to state that the queue is empty, and so nothing can be deleted from it. Last function is display. So if you have to display the elements, for displaying also you have to check if the queue is empty or not, because if it is empty, there are no elements, what are you going to display? So if it is not empty, then you have to use a for loop starting from A front plus 1. Here I've given I equal to A front plus 1 because A front is initially initialized as minus 1 because the queue was empty in the beginning. So if the front part will start from 0, so minus 1 plus 1, 0, and less than equal to A rear, I plus plus, you just have to display the elements. And if it is empty, just display that the queue is empty, because if it is empty, you cannot display anything. Now I hope you understood the program. It's easy. Let's just build and run and try it. So enter the size of the queue. We'll go with something small, right? 2. Enqueue operation. Enter the choice 1. Enter the element 23. Do you want to continue? Yes. You would like to insert another element. Do you want to continue? Yes. Now let's just, the size of the queue is 2. I've already inserted 2 elements. I'm trying to insert another element. What is the expected output? It should state that the queue is full. Let's just see if it is full or not. So the queue is overflowing, right? I hope you understood that. So that's one part of it. Now let's try for another part. Enter the size of the queue 2. Delete. So I want to insert some element first of all. 23. Yes, I want to continue. Now I want to delete the element. Deleted element is 23. Now if I want to delete another element, I do not have another element. I inserted one element. I already deleted one element. Now I am trying to delete another element. So it is stating that the queue is empty. Right. One more, we'll just go for the display function. Enter the size of the queue this time to enqueue, enter the element 23. Yes, I want to continue. Enqueue again, 23. Yes, I want to continue, and enter the choice. This time I'm going to enter 3. I want to display it. So 23, 23. Right. So that's the end of the program. I hope you understood. There are various applications of queue. For example, in operating system, It is used, various jobs come and the order is there, so their jobs wait in a queue, so their queue is applied to sort out which job should get get the CPU first. And then there are various real life applications also. For example, you wait for a movie ticket in the queue, and then you wait in a shop in the queue. And so queue can be applied to various real life examples also. I hope you understood the program. Thank you.